thing I want to do is define what a regression line is. You say regression line, it's going to make you sound really smart. But regression line is the line of best fit for certain criteria. Okay, let me explain what I mean by that. It's on the bottom. Okay, so back when you were in middle school, I think things changed. So tell me if I'm wrong. You would graph a scatter plot, and they would say, just kind of put your ruler so it's like the same amount of points above the line as below the line. Does that sound right? Okay, and then I know in biology you're supposed to graph scatter plots, and they would tell you to try to make like the distance to the points above the line the same as the distance to the points below the line. Like try to, you know what I'm talking about? Like you take your ruler, let's actually try to do it real quick. So get your packet out. We're just gonna eyeball it right now. And I want you to look at this. We're gonna use this graph for a lot of days. But you don't need to do anything right now. You're just watching me. Just like middle school, you would have been like, oh, let me try to get the same amount of points above the line, below the line when I draw my line of best fit, right? Do you remember this? No? I don't know if they do it anymore. Okay. Okay, but they would say, try to wing your ruler like in the middle of the data somewhere. Okay, in stats, we have much more sophisticated criteria to make our regression line. So, however, this is the actual definition. Guys, I think that somebody took 2 of them because it seems to be out of them. So I'm gonna have to make you one. How did you? How? It wasn't really a how for you. Just no, I know. I'm just saying somebody, 2 people took 2 somehow. But it's okay. I have the master. I will copy them as soon as I'm done. Jake came, so this is my thinking. Jake came second period and grabbed some, and I wonder if he grabbed them for you guys or no? He wanted 4 for himself. That makes sense. Okay. All right. So, the actual regression line equation. So you guys are used to y equals mx plus b. In stats, we do it a little bit different. So lines are usually y equals mx plus b, right? Okay, in stats, this is called y hat. It's literally called y hat. I did not make that up. That's not a Mrs. Talbot fun thing. It's actually called y hat. And it's y with a little hat over it. And the little hat means predicted. It means not exactly. Because you're working with a scatter plot, right? So that's saying predict y equals a. A is the y-intercept. So like the b for y equals mx plus b. And then b is the slope. Doesn't it make more sense, in your honest opinion, that you graph the y-intercept first and then graph the slope? I don't know why in math class we put mx plus b and then we graph the second thing first and then graph the slope off of it. Doesn't this make more sense? Graph the y-intercept and then the slope off of that. Anyway, this is what we use. Okay, so use the sugar versus calories graph to make the following predictions. Predict how many calories a candy with 65 grams of sugar would have. Okay, you don't have enough information to do this at the moment, but I sort of cheated. I worked ahead. Before you get nervous about that, there is going to be a day on the assignment sheet where it says stuff on the calculator. Did you see that? It says, is this the block day? Oh, tomorrow. Okay, we're gonna do a bunch of stuff on the calculator tomorrow, but you don't know how to do it yet. So you just have to kind of trust me. The equation for this is something. It is y hat equals 300.040 plus 2.829x. Okay, how did I get that? I'm going to teach that to you tomorrow. Don't worry. This lesson is about making predictions. Okay, so here's my question. How many calories a candy with 65 grams of sugar would have? So look at your graph. Is sugar X or Y? X. Okay, so you're going to say, okay, that's easy. X equals 65. And you're going to plug 65 into the equation. Just for time's sake, do you guys trust me to use last year's number? Are you guys confused? Do you need help? It's because it's not exact. So if you think about the scatter plot, I want you to think about me drawing a line here, but the actual coordinates are off the line. So this is like estimated y. We say the word predicted. So predicted y equals a plus bx. So we predict that a candy with 65 grams of sugar would have about 484 calories. We don't know for sure, but that's what our mathematical model would tell us. So that's what the hat, like, this is going to sound terrible. And I know I'm recording this video, but it kind of like covers your ass. It's like, it's like, I don't know for sure. It's an estimate. So I'm saying predicting in the little white hat covers me. Okay. Now you won't forget. here's the funny thing. We don't really write X hat. Even if we go backwards on B, can you guys tell we're gonna go backwards? Because it gave us the calories this time.
Yeah.
We don't really write X hat. We don't really write like X predicted. So we're just gonna put Y hat equals 700. And then we're gonna plug that in. So 700 equals 300.040 plus 2.829x. And then we're going to use our algebra inverse operations to solve for x. You can. The thing with stats is like it's all kind of an approximation. So, okay. So how do I undo this? What would I do first? Yeah. Okay. I want you to write C if you haven't already, and then I want you to, on your own, figure out if 250 is an X or a Y, plug it into the equation, and solve it. Don't answer the confident part, leave that for me, but just practice your prediction. Alrighty. Let's see if you got it. Get 1007.29 calories. Okay, now, how confident should we be with this prediction? To answer that question, we need to look at our graph. So let's find 250 grams of sugar on our graph. It's not on there. So how confident should we be? Any questions so far about what we've done? We good so far? Okay, now doing this, making a prediction very far down the x-axis, either way, is actually called extrapolation. There is a vocab word for what we just did.
Extrapolation is the use of a regression line equation to make predictions outside of the X values in our data. Whatever this is, can you knock this off, please? Okay. Last topic. It's going to take us a little while, but it's the last topic. It is residuals. So we're learning three things today. We're learning predictions, extrapolation, and residuals. Although I want to go back into the sugar versus calories graph and do a tiny bit of review of what we've already done on some things. But residuals. Okay, can you guys get some of you, get your sugar versus calories graph out? Okay. Actually, can you all do me a favor? Did you write this? I already wrote that. Okay, what we're gonna do is I'm gonna put the next thing up for you to write, and while you're doing that, I'm gonna print myself another sugar versus calories graph because I gave them mine. No, no. Just write this and I will print mine. Okay, when you're done writing this, just get your sugar versus calories graph out. We're gonna put some stuff on there. You also might want a ruler.
Clear.
All right, everybody good? Okay, so let's pause our lesson for a second. And then let's look at, hold on. Let's look at this. Okay, so what we're going to do is a tiny bit of review of what we've done in this chapter so far before we move on to the residuals on here, because we have to draw them on here. We need to get it set up. Okay, first, what was the very first thing we learned in the chapter? Explanatory and response. What is the explanatory variable? In grams? You can tell because it's on the X, and explanatory has an X in it. What is the response? Calories. Okay, now it's more than that. It's more than just being an X. Doesn't the amount of sugar determine how many calories something has? Okay, so just because they're graphed on here doesn't mean that explanatory and response are clear. It is on this one though. Going back to last Tuesday right now. Yeah, okay. The next thing we learned how to do was to graph a scatter plot. That's already done for you. Okay, next thing we learned how to do was to describe a scatter plot. And we use dots to describe a scatter plot. This particular description we're going to do right now is going to be kind of sparse. Remember when I was teaching you stuff in the summer work and we did socks, and we did socks kind of lame, and then we came back and did it for real at the end. Okay, so we did socks just based off the picture as an estimate. We used range and like dumb stuff like that. And then I actually taught you how to find statistics, and we went back in and put the actual like center and spread. So it's going to be like that again. We're going to do kind of the lame doffs right now. Okay, can you tell what the direction is? Positive, yeah. Very soon, we're going to add statistics to this that will prove that it's positive along with the picture. Outliers. maybe this guy. Okay, so if you notice in your packet, the actual coordinates are given to you on the next page. If you flip the packet over, you can see the different candies. Which one is the possible outlier? It should be like 79, 790 or something. Is it 79, 790? Okay. Remember, in chapter 3, there's no way to tell if something's an outlier or not. You just put possible. There's no like IQR rule or anything like that. Okay, form. Just from your gut, does it look linear? Yeah. That's all you got right now. And strong, moderate, or weak? I would say moderate, just from looking at the picture, but I will spoiler alert for you. Not alerting. I'm alerting myself on my almost spoiling. R is 0.618. How do you know that, Mrs. Talbot? Well, because I know how to do it on my calculator, but you don't yet. Does the 0.6 make sense in your mind for it to be moderate?
Yeah.
From our discussion on last Friday? Yeah. Okay, now interestingly enough, because I just spoiled that for you, you can also put that here. Why does this justify the positive direction? Because it's a positive R, right? So positive R's mean positive direction. And also we looked at the graph and whatnot. Okay, next thing we learned was correlation. R equals 0.618. I found that using my graphing calculator. I'm going to teach you that tomorrow. And then there's that sentence that we wrote down after I stopped the video and I realized I hadn't taught you the sentence and then we wrote the sentence. So that is the interpretation of correlation. Okay, now we're at today. We did a bunch of prediction stuff, which is great. And I also told you the equation of the line of best fit. The regression line is 300.040 plus 2.829x. And that seems like magic because you don't know how to do it, but I promise I will teach you tomorrow. Okay, the next thing I want to teach you is how to graph this on your graph. I can't graph the y-intercept and slope here. Do you see that that would be kind of impossible? It starts at 40 and the slope is 2.8 and these are going by hundreds. Okay, so the best plan is to plug in a number on the left and plug in a number on the right. What is the very most left number on the x-axis? 40. If we plug in 40, we can find a coordinate on the line at 40. I'm going to switch colors just in case you're, that type of note taker like I am. Okay, so scroll up 40 comma 413.2 and just do your best. 40 comma 413.2. Okay, now what is the number on the very far right of the x-axis? 140. Okay, I graphed 140 comma 696.1, which is basically 700. This is the moment when you want to take that ruler and draw in your line of best fit. There are some parts that remain a mystery to you. That's okay. How we get R, how we get the equation, that I will be teaching you tomorrow. Don't worry. Okay, when you're done with this, head back to your notebook. Yeah, better, right? Okay. We just reviewed a lot of really good stuff there. Okay, now go back to your notebook. What's wrong? Why is the y-intercept what? This starts at 40 though, not 0. So you'd have to backtrack it to 0 and then it would be 300, but we don't have 0, we have 40. And that's going to happen a lot with scatter plots. They're not going to start at 0. So, okay. That's later that day. Just get this down and then I'll explain it all to you in terms of an example. It'll make a lot more sense after we do an example, I promise. When you're done with this, flip it back over to what you already wrote in the example section. Anybody still writing? Totally okay if you are, just let me know. Okay, let's do the example. It'll make 1,000 times more sense. Okay, use the sugar versus calories graph to calculate the following. Calculate, interpret, and draw the residual for peanut M&Ms at 79,790. Okay, residuals are vertical lines from that point on the scatter plot to the regression line. What you're going to do is take your ruler and you're going to go to this one, which was the 79,790. And you're going to draw in the residual. The residual is the amount of error. How far off was the line in predicting the amount of calories in this particular candy? It was really bad, right? Really, really off. Okay, so we would expect the residual to be a very large number. Are you guys with me so far? Okay, so residual is a vertical line drawn on a graph, and it represents the difference between the actual y, which is 790, and the predicted y, which is whatever the y is right here. Okay, so it's the length of this segment. Okay, so going back to my formula that I wrote down. So residual equals y minus y hat. Okay, what was y at that coordinate? 790 minus, and then y hat is the equation. Does it make sense to you guys that this would be the predicted y at 79 grams of sugar? So to find the predicted y at 79 grams of sugar, I would plug it into the equation, and then the actual minus the predicted is 266.469 calories. Okay, so we're going to come over here. This is 266.469 calories. And this point is 79, comma, what the heck was it? Hold on. $76. That's plus. That's supposed to be plus. That's supposed to be plus. That's a plus. 523.531. Do you guys understand where I got the 523.531 from? I plugged it into the equation, 79. No? What? Yeah, it's this part. So it's how far away it is. Okay, now let's do this one. What is the actual calories for candy with a residual of 194.436? Does it make sense to you guys that y is going to be the variable here? Because it's actual y minus predicted y? No? Because it says, what is the actual calories? So this is actual minus predicted. Okay, so y minus 44 grams of sugar and then add to both sides. Look at us, we had to do algebra today. Okay. I have 5 minutes left of your time. I did not interpret the residual here. So I need to write the sentence for that, and then I'll save the rest of it for tomorrow. Hopefully I'll have time. It's not long, but it's not a big deal. So let's go over to here to interpret the residual. And then we'll be done. And we'll only do the first one just because of time. So we're just gonna do, oh, we only had to do the first one. Calculate, interpret, and draw the residual for peanut M&Ms. Okay, let's flip back to the sentence. It says, in the difference between the actual, okay, and then it says difference between the actual y units. What's the y units on this? Calories. And predicted calories is 2.66, no, 266.469. that sentence is the interpretation for that vertical line that we drew to interpret the residual 266 away.